One of the most successful and enduring feats of interplanetary exploration, NASA's Mars Opportunity rover mission, has finally been declared over after almost 15 years exploring the surface of the red planet. The golf cart-sized six-wheeled robotic rover stopped communicating with Earth on June the 10th last year as a massive global dust storm enveloped the red planet, blanketing the rover's location and blocking out the sunlight needed to recharge the rover's batteries. Opportunity was expected to revive after the storm had passed, and its batteries would then be recharged from its solar cells. But when the storm finally abated and the dust cleared in August, the rover remained silent. Mission managers at NASA's Jet Propulsion Laboratory in Pasadena, California, believe R.I.P, as it's affectionately known, likely experienced a low power fault, a mission clock fault, and an up-lost timer fault, all due to the loss of power. It's thought that dust from the storm had covered its solar panels, preventing them from receiving sunlight. Normally strong Martian winds, which usually begin blowing around November, would have blown the dust off the solar cells. That then would have allowed the batteries to recharge and operations to resume. But the rover still remained silent. NASA tried sweep and beep commands designed to nudge the rover to send a response once the rover had powered up again. But despite more than 1,000 attempts to re-establish contact, Opportunity still hasn't phoned home. And so the decision's now been taken to formally end the mission. Originally designed to last just 90 Martian days and drive no more than a kilometre across the freeze-dried desert surface of the red planet, Opportunity remained operational for more than 14 years, travelling over 45 kilometres. Its final resting place, appropriately named Perseverance Valley, a gully leading off the rim of Endeavour Crater. During its mission, Opportunity revealed an uncharted Martian landscape, finding evidence that Mars was once a far warmer, wetter world, a world capable of supporting life as we know it. The final transmission formally ended a multifaceted 8-month recovery strategy, desperately attempting to compel the rover to communicate. Manager of the Mars Exploration Rover's project at JPL, John Callis, says his team have made every effort to try to recover Opportunity, but have now determined that the likelihood of receiving a signal is simply too low to continue. Opportunity landed in the Meridiani Planum region of Mars back on January the 24th, 2004, 7 months after its launch from the Cape Canaveral Air Force Station in Florida. Its twin rover Spirit landed 20 days earlier in the 166-kilometre-wide Gusev crater on the other side of Mars. Spirit logged almost 8 kilometres before its mission finally wrapped up in May 2011. By that time, it had become bogged in a sand dune with its solar panels facing away from the sun. From the very day the two rovers landed, mission managers, rover drivers and scientists collaborated to overcome challenges and get the vehicles from one geologic site on Mars to the next. They plotted workable avenues over rugged terrain so that the twin 174-kilogram Martian explorers could maneuver around and at times over rocks and boulders, climb gravel-strewn slopes, probe crater floors, summit hills, and traverse what looked like dry riverbeds. In 2005, Opportunity lost steering to one of its front wheels. A stuck heater then threatened to severely limit the rover's available power, and ripples on a Martian sand dune almost trapped it for good. 2 years later, a global dust storm on Mars imperiled the rover before relenting. Then in 2015, Opportunity lost use of its 256-megabyte flash memory, and in 2017 lost steering to its other front wheel. Each time the rover faced an obstacle, mission managers back on Earth found a way to implement a solution that enabled the rover to continue its mission. Opportunity's final venture brought it to the western rim of Perseverance Valley. However, the massive dust storm which took shape in May and June of last year proved just too much. Opportunity's journey included a one-day Mars driving record distance of 220 metres. That was set back on the 20th of March 2005. Oppie also returned more than 217,000 images, including 15 360-degree colour panoramas. It exposed the surfaces of 52 rocks to reveal fresh minerals for analysis and cleared 72 additional targets with a brush to prepare them for inspection with spectrometers and a microscopic imager. It found little round blueberry-like concretions of hematite, a material that forms in water at its landing site. The findings all supported the primary objective of the Mars Exploration Rover's mission, to seek out historical evidence of the red planet's climate and water at sites where conditions may once have been favourable for life as we know it. Because liquid water is required for life as we know it, Opportunity's discoveries implied that conditions in the Meridiani Planum may well have been habitable for some period of time in Mars's ancient history. Principal scientific investigator for the Mars Exploration Rover's mission, Steve Squires from Cornell University, says combining the discoveries of the Opportunity and Spirit rovers confirmed that ancient Mars was a very different place from the cold, dry, desolate world we see today.
This mission accomplished so much more than we wanted to. It's mind-boggling to me. We know more about Mars today than we knew 2 days ago. Both rovers together showed us that ancient Mars was much more habitable, was much more Earth-like than Mars is today. Mars today is a very cold, very dry, very desolate place where not much happens. If you go to the ancient past, compelling evidence for hydrothermal activity, hot water bubbling through the rocks, steam vents, water coming up to the surface, volcanic explosions, lots of impact craters. It was a hot, violent, steamy place. And it was the kind of environment that would have been suitable for some kinds of microbes. All of it very different from the Mars of today. Different places that were visited by the two rovers, different from one another. And it sort of hints at the complexity that the entire planet must have. This was a great teaching tool. It's been said many times that some of the most important scientific discoveries begin with the words, "That's odd." You see something totally unexpected and then you follow it. To take that kind of immediacy of discovery and the true nature of science into the classroom, it was an opportunity to share with them science as it really happens. I work with engineers today who were 18, 19-year-old Cornell undergraduates at the beginning of the mission and actually built hardware that's on the rovers. There's hardware on the rovers that was built by Cornell undergraduates. They put their initials on it and everything. I can see by the career path they've taken, the trajectory that their career has taken, that opportunity early in the mission opened doors for them, at least in their own heads in terms of what they thought was possible for them. I mean, if you had told me around the time we landed that Spirit and Opportunity were going to each accomplish 1/4 or 1/10 of what they ultimately did, I would have been thrilled. And it's because of the longevity of the vehicles. Spirit lasted 6 some odd years, Opportunity 14 and a half when we were designing them for 90 days. Mars just kept giving us new stuff. And so the payoff has been immensely greater than anything any of us ever in our wildest dreams conceived of. We have changed the way in which people perceive Mars. Every morning, you can open up your computer and you can go to a public website and you can see new vistas of Mars. They're always someplace new, and we're climbing mountains and we're descending into craters and these beautiful panoramas, and all of a sudden Mars becomes a place that humans can relate to, that you can imagine being. You've got these machines that are there that are built on very human scales, doing very human-like things. The kind of exploration that we do with rovers is very, very accessible. It's easy to understand. These are robots. They're looking at rocks. It's not that complicated. And I always felt that the unique accessibility of this mission gave us both a special opportunity and a special obligation to really try to share it with the public. And we've tried very, very hard to do that. And if part of the legacy of this mission is that a whole bunch of young people who saw that thought that's really cool, but I bet I could do better, if that thought hit them and it helped to push their career in a certain direction, that ultimately could be possibly the most important part of our legacy.
That's Steve Squires from Cornell University. Of course, Mars exploration continues unabated. NASA's InSight lander, which touched down on the red planet in November, is now beginning its scientific investigations. The Curiosity rover has been exploring Gale Crater for more than 6 years now, and it's continuing to go strong. Nuclear-powered, using radioactive isotope decay, it doesn't need to concern itself with the threat dust storms pose to solar panels. And NASA's Mars 2020 rover and the European Space Agency's ExoMars rover will both launch in July 2020, specifically designed to seek out signs of past microbial life on the red planet. An armada of satellites are also orbiting Mars, sending back data on its atmosphere and spectacular images of the red planet's surface from orbit. But because of its perseverance, because of the fantastic images it provided and the new windows on Mars it opened up, Opportunity's journey will always have a special place in the history of Martian exploration.